Hello, this is Jason Ott, and this is my final project for Computer Science 110, Fall 2014. Uh, this is my project where I use the turtle module to write a program that will draw the skeletons of the 5 basic platonic solids plus 2 of the additional special platonic solids. First thing we're going to do is take out a little tour of the code. So all the code for the program lives in these 2 modules. We have the shapes module, where we import the turtle module itself. Also from the math function, we import the sine and radian functions. And then from the random library, we import the random integer function, which we're going to use to do some things with designs that are inscribed in the shapes. So through here, you'll see the function definitions for the triangle function, the square function, pentagon, hexagon, and then you've got 2 isosceles triangle functions. One is a left-handed one, and the other is right-handed, which we'll use these 2 together for the great dodecahedron. Then the center poly function. This calculates the center of a regular polygon using the sine and radian functions from the math library. It returns the center, and we use that to decide the placement of the designs that we create to go on each side of the polygons. So then we have the designs here, the sunburst function, which uses the circle function from turtle and some of its unique parameters to draw different shapes besides circles, using the extent function right here, or extent parameter right here, to determine how many times it goes around the circle, and the steps to determine how many steps it takes in drawing the pattern of the circle, which in this case results in the sunburst. We also have the circles function here, triangle hex function, which draws a triangle inscribed inside a hex, the figure 8 function, which will just inscribe 2 circles in a figure 8 type pattern, different size, centered on each shape, but at a random orientation using the rand_int function each time. The pentastar function, and this one here does a 5-pointed star, which we inscribe inside the pentagon. So that is the shapes module. Then over here in the platonic solids module, we have the actual code to draw the solids. So we start off by importing everything from shapes here. Then we have the tetrahedron and the cube, the octahedron, the icosahedron, the dodecahedron, the truncated icosahedron, and the great dodecahedron function here. And finally, this module finishes off with the main function, which provides the interface for the user to use to decide which shape to draw. Right here, the decision tree that controls the shapes and calls the functions and sets the parameter of the size. And then finally at the end, once you've had the shape drawn and close that particular one, it gives you the choice to draw another one if you wish as well. So that's the code. Next we're going to start by demonstrating the project here for you. Okay, so now we're going to demonstrate the code. So we'll start by opening the program here in the shell. And it pops up with the interface here. Ask what shape you'd like to draw and gives you the choice of the 7 different shapes. So we'll start off with the tetrahedron this time. So once you select the shape to draw, it pops up a screen here for the turtle, which has been sized by the program to take up the whole screen on my computer here. Then it starts drawing the triangle shapes by calling that function, and then once it finishes the triangle, it calls the design for the circles function, which it inscribes inside there after figuring out the center using the center poly function. Now if you notice, each one of the circles here, they actually seem to start in different places because we use the rand_int function to control the extent to which the circle is drawn. So each time it goes around and draws the circle here, it first draws 360 degrees, and then it calls a random integer between 90 and 360 degrees, travels that far, and then starts to draw the next circle in there, which is 2/3 the size of the one before. And then we'll do the same thing, calling a random integer to go around past 360 degrees, and then draw the last circle as well. So that each one of the faces of the tetrahedron is unique. Also, each time you draw this shape, it will come up with a unique result as well. Up here at the top of the window, you'll see that they actually use instructions here. So once you're finished with this particular shape, you can click the window to exit, and it returns control back to the main function. So back at the menu here, it gives the choice to draw another polygon. You can hear yes or no, so we'll put in yes to get another one. This time, let's go ahead and do the dodecahedron. So again, it calls up the screen here and begins to draw the shape for us. So the pentagons are each done in maroon, and that color has been entered into the function that calls it up each time, and then it draws the star inside it using the center poly function to figure out where the center is. It also takes advantage of the fact that the skeleton here is rotationally symmetrical. So once it starts from here, draws the initial shape, the turtle is then sent back to its home and then moves to the spot where it starts drawing the second half of the shape here, and then it continues around to finish the shape. So we basically make two passes through a loop with a reset in the middle and then a change in the orientation of the turtle so that it draws the mirror image of it rotated around by 180 degrees. So let's draw another one here. This time we'll do the truncated icosahedron. So this one here, much larger shape. And this also takes advantage of the symmetry of the shape to use a loop to go through and draw. This arm here is very much the same 5 times. So it starts off by drawing the pentagon in the middle, then draws this first arm. Then at the end of the first pass of the loop, the turtle's position is sent back to home. Then it moves over to the next position, saves this position as its new home, draws the next arm, returns back, and continues around so it passes through the loop all 5 times. At the end of the 5th loop, it draws one more pentagon over here at the end that it uses basically will be opposite this one, so it's basically the cap that will connect all 5 arms together. And then we're going to do one more shape this time. So we're going to demonstrate one more shape for you here. We're going to do the great dodecahedron. So this one is the one I was talking about that uses 2 different isosceles triangles. We have the right-handed one that points off to the right, and we have the other one that points off to the left. As it goes through and draws these, using the 2 different triangles enables it to progress a little bit faster because it doesn't have to shift quite as far to go into position to draw the next shape. So this shape also uses 5 identical arms. This one here, instead of having a shape at the middle, it just starts from a single point. Draws the arm at the end of that particular loop. It returns back to the home, and then it changes the heading by 72 degrees to the left and draws the next arm. So all 5 arms here are identical. And you'll also notice as it draws here that there's no actual turtle visible on the screen. We've actually set the turtle to be invisible. I did that so that it would go a little bit faster. It has less of a strain on the program as it draws the graphics this way. So it actually progresses a little bit quicker by having the turtle invisible rather than having it actually shown on screen while it's doing the drawing. And that is the great dodecahedron. Well, thank you for taking the time to watch my project here. Again, this was using the turtle module within Python to write a program that enabled us to draw the 5 different primary platonic solids along with the 2 special solids as well. I didn't demonstrate the cube, the octahedron, or the icosahedron this time, but those all work very much the same way. Each time it will call up the screen, do the shape for you, and then you can click the screen to close it out and return to this menu whenever you're done. And then when you've had enough shapes drawn, when you're finished playing with the program here, you can just hit in and it will quit for you. Well, thanks again for taking the time to watch this. I hope you learned something about the turtle module, and goodbye.